Good morning to all of you. In previous session, we have seen the multiplication of two DFTs property of discrete Fourier transform, as well as we have seen how to determine the circular convolution by using its formula. So today we'll be identifying circular convolution by using multiplication of two DFTs property. Right. So as per the multiplication of two DFTs property, if we have two discrete times signals x1 of n and x2 of n with their respective endpoint DFTs indicated as x1 of k and x2 of k. Okay, then the circular convolution, that is x1 of n circularly convolved with x2 of n in frequency domain, it is nothing but the multiplication of their respective discrete Fourier transforms, right? And we indicated this circular convolution as x3 of m, which is nothing but n is equals to 0 to n minus 1 x1 of n multiplied by x2 of m minus n, okay, with n suffix. So here these folding and shifting operations are performed circularly. Okay, this difference we have seen between the linear convolution and the circular convolution in previous session, right? So today we'll be determining this circular convolution by using DFT property, that is multiplication of two DFTs, correct? So initially we'll be determining the given sequences discrete Fourier transforms, and then we'll multiply their respective DFTs, and then we'll take the inverse DFT of the resulting product uh, result, and then by taking this inverse DFT we will get the circular convolution of these two sequences, right? So here is the example. The same sequences has been taken here, what we have taken in the previous session, so that your result should get cross verified, right? So here we will be determining the sequence x of n. So this x of n is nothing but the circular convolution of these two sequences, so that is x1 of n and x2 of n. But here we will be determining the circular convolution using discrete Fourier transform and inverse discrete Fourier transform, that is nothing but multiplication of two DFTs property, correct? So first we compute the DFTs of x1 of n and x2 of n, okay, by using the 4-point DFT, that is endpoint, because there are 4 samples in each sequence, so that DFT will be called as what? 4-point DFT, right? So the DFT of x1 of n will be indicated as x1 of k, and its formula will be n is equals to, it will vary from 0 to 3, right? Because it will be capital N minus 1. Okay, the formula for DFT is x of k is equals to summation n is equals to 0 to n minus 1 x of n into e to the power minus j 2 pi k by n. Okay, so this is the k n by n. Okay, so this is the formula for what? DFT. Okay, discrete Fourier transform. So here the value of capital N is nothing but 4, because 4 samples are there, right? So here we'll be writing x1 of n into e to the power minus j 2 pi n k by n, right? So here we'll have the value of k, okay, as we have seen in the formula. So k is 0, 1, 2 and 3 in our case. Okay, so here it is nothing but 0, 1, 2 up to n minus 1, right? So this x1 of k, as per this formula, if I'm substituting the values of n here, so it will be x1 of 0 into e to the power 0, right, plus x1 of 1, x1 of 1 into e to the power minus j 2 pi k by, as n is 4, so it will be pi k by 4, I will write, right? So plus x1 of 2 into e to the power minus j 2 pi. So n is substituted 2, so it will be 4 pi, because 2 multiplied by 2 will be 4, k by 4 will be there, right? Similarly, x1 of 3 multiplied by e to the power minus j 6 pi k by 4. Okay. So this is what we have. So if I'm substituting the value of x1 of 0, so x1 of 0 is 2, so it will be 2, right? Plus this x1 of 1, so x1 of 1, so this x1 of 1 is 1 here, right? The value of x1 of 1 is 1, so I can write it down e to the power minus j pi k by 2, right? Because this 2 divided by 4 will be 1 by 2 simply, right? Plus this x1 of 2 is 2, so again 2 multiplied by e to the power minus j pi k, this 4 will get cancelled, okay? Plus the value of x1 of 3, right, is 1 again, so it will be e to the power minus j 3 pi k by 2, correct? So this is nothing but what x1 of k is, right? So this is the equation that we get here, right, for x1 of k. Now you have to substitute the values of k is equals to 0, 1, 2 and 3 to get the value of x1 of 0, x1 of 1, x1 of 2 and x1 of 3, right? So I'll just rewrite down this equation here. X1 of k is equals to what we have, 2 plus e to the power minus j 2 pi k by 2, e to the power minus j pi k by 2 plus 2 into e to the power minus j pi k plus e to the power minus j 3 pi k by 2. Okay, so this equation we have. Now if you substitute k is equals to 0, right, so you will get equation 2 plus e to the power 0, correct, plus 2 into e to the power 0 plus e to the power 0. That means 2 plus 1 plus 2 plus 1. Okay, so you will get x1 of 0 is equals to 6, right? Similarly, if you identify x1 of 1, right, by substituting k is equals to 1 here, so it will be 2 plus e to the power minus j pi by 2, right? So you can determine it by using cos pi minus j sin pi, right? Plus 2 into e to the power minus j pi, so it will be cos pi minus j sin pi, right? Here it will be e to the power minus j 3 pi by 2, so it will be cos 3 pi by 2 minus j sin 3 pi by 2. So after substituting those values, you will get the value 0 here, right, after adding all those values. Okay, so you can compute those values directly on calculator, or you can identify the values in terms of cos and sine, right? Similarly, x1 of 2, if I am substituting k is equals to 2, so again here I will get 2 plus e to the power minus j pi, right, plus 2 into e to the power minus j2 pi plus e to the power minus j3 pi, right? So again it will be value 2, right? And then if I'm substituting k is equals to 3, so it will be 2 plus e to the power minus 3 pi by 2 plus 2 e to the power minus j3 pi plus e to the power minus 9 pi by 2, right? So here the value after evaluation of that equation will be 0. So these are the values of x1 of 0, x1 of 1, x1 of 2 and x1 of 3. Similarly, you can determine the DFT. So the DFT of x2 of n. Okay, so the formula for that will be x2 of k is equals to summation n is equals to 0 to 3 x2 of n into e to the power minus j2 pi k n by n, right? So again x2 of k, if I'm substituting the values of this n variable, and the value of x2 of that is sample values. Okay, so what equation I will get, because x2 of n is 1 2 3 4, so it will be 1 multiplied by e to the power 0, so it will be 1, right? Second value of the sample is 2, so it is 2 multiplied by e to the power minus j is it will be uh, 2 multiplied by 1 divided by 4, because value of n is 4, so it will be e to the power minus j pi k by 2, right? Plus 3 into e to the power again minus j, 2 multiplied by 2 will be there, 4 by 4 will be 1, so it will be minus j pi k, right? Plus 4 into e to the power minus j 3 pi k by 2, right? So this equation I will get for x2 of k, capital X2 of k. Okay, so similarly again I will put these values, k is equals to 0 1 2 and 3, right? So this x2 of 0 will be, after substituting these values, so it will be 1 plus 2 plus 3 plus 4, so it will be 10, because e to the power 0 e to the power 0 e to the power 0 will be 1, right? Similarly x2 of 1, so I'll get equation 1 plus 2 into e to the power minus j pi by 2, right? Plus 3 into e to the power minus j pi, plus 4 into e to the power minus j 3 pi by 2. So after evaluating that equation, I will get minus 2 plus j2, right? Or twice j, right? Similarly, x2 of 2 is equals to, so again I will substitute 1 plus 2 into e to the power, this minus j pi will be there, 2 will get cancelled, 3 into e to the power minus j2 pi will be there, plus 4 into e to the power minus uh, 3 pi e to the power minus j3 pi will be there, right? So it will be, after evaluation, minus 2 value will be there. Similarly, x2 of 3, so if you substitute 3 value, so after evaluation you will get minus 2 minus j2 value, right? So I'm directly writing these values. You can just cross verify these values, right? By calculating on calculator, or maybe by evaluating in terms of cos and sine, right? So as per this multiplication of two DFTs property, to get the convolution result, now we had to multiply this sequence. Okay, so I can indicate this multiplication result as x1 of k multiplied by x2, capital X2 of k. Okay, multiplication of these two DFTs, right? So this x1 of k and x2 of k, after multiplication, will be their respective samples, that is these respective sample, that is x1 of 0 will get multiplied by x2 of 0, so this multiplication result will be 60, right? That will be your x of 0. Similarly, x of 1 will be this x1 of 1 multiplied by x1 of, sorry, x2 of 1. Okay, so if you multiply these two values, so 0 multiplied by n will be 0, then this x1 of 2 will be, sorry, x of 2 will be x1 of 2 multiplied by x2 of 2, so this minus plus will be 2 minus 2 multiplied by minus 2 will be minus 4, right? So it will be minus 4. And similarly, x of 3 will be, again it is value here, it is 0, so 0 multiplied by this value will be 0. Okay, so this is what we have as this multiplication result. Okay, multiplication of these two DFTs. But to get the convolution result, okay, so this convolution is nothing but we have to determine the sequence x of n. So this convolution, that is circular convolution, as per the circular convolution, so we'll indicate it as x of n, that is nothing but the you can say that it is the inverse DFT, okay, of x of k. In time domain, it is nothing but the circular convolution of x of n, and so it will be x of n, or I will indicate x of m. Okay, so x1 of n multiplied by x2 of m minus n. Okay, So to get this sequence, that is circular convolution result, we have to take the inverse discrete Fourier transform, that is IDFT of this x of k, right? So to I will indicate this inverse DFT as x of n of x of k, and the formula for that, as per the IDFT formula, it is 1 by n summation k is equals to 0 to n minus 1 x of k. Okay, that is nothing but this multiply x of k into e to the power j2 pi k n by n. Okay, as per the IDFT formula. Okay, I'll just rewrite down this inverse DFT formula, that is 1 by n summation k is equals to 0 to n minus 1 x of k into e to the power j2 pi k n by capital N. Correct? Now here I will put the values of this n is 4 in this case. Okay, so it will be k is equals to 0 to 3, right? X of k into e to the power j 2 pi k n by 4 will be there. Correct? So again, here I can substitute the values of k here in this equation, so it will be 1 by 4, right? So if I'm substituting k is equals to 0, so x of 0, so x of 0 I have determined here 60, so it will be 60 multiplied by e to the power 0, so it will be 1, right? Then for k is equals to 1, so x of 1 is 0, right? So 0 multiplied by this value will be 0 simply. Then x of 1 will be the x of 2 will be there, k is equals to, for k is equals to 2, so x of 2, the value of x of 2 is minus 4, so I'll have this minus 4 in this case multiplied by e to the power this 2, basically this k is equals to 2, I am substituting 2 multiplied by 2 will be 4, right? So 4 will get cancelled, so it will be simply j pi n, right? So it will be j pi n, and then last value of k will be 3, so x of 3, so x of 3 is again 0, so this value will be 0, so this is nothing but your x of n. Okay, that is the circular convolution result. But to get the actual sample values, again you have to substitute the value of n here. So again n will be varying from 0, 1, 2 and 3, right? So I'll get x of 0 is equals to, so if I'm substituting n is equals to 0, so 1 by 4 multiplied by 16, 60 will be there, minus 4 into e to the power 0 will be there, so 60 minus 4 will be 56, and the 1 by 4 multiplied by 56 will be 14. Okay, similarly x of 1 will be 1 by 4, again in bracket 60 minus 4 into e to the power j pi will be there, as I'm substituting n is equals to 1 here, so it will be cos pi plus j sin pi, right? So it will be 1 minus 1 value will be there, so it will get added, 60 plus 4 will be there, so 64 multiplied by 1 by 4, so it will be 16, right? Similarly x of 2 will be, again it will get evaluated 60 minus 4 multiplied by e to the power j 2 pi. Okay, so it will be cos 2 pi plus j sin 2 pi will be there. Okay, so again it will be having value 1, so 60 minus 4 will be the 56 will be there, so again it will be 14, and the final value for n is equals to 3, so 1 by 4, 60 minus 4 into e to the power j 3 pi will be there. Okay, so after evaluation it will be minus 1 value, minus plus will be the plus 4, so 60 plus 4, 64 will be there, the value will be 16. So this is what we'll get as the circular convolution result. So the circular convolution of x1 of n and x2 of n, as it has been asked in the example, which is nothing but the corresponding sequence x of n, is x of n is equals to, which we had indicated previously as x3 of m. Okay, so this x3 of n is nothing but the x of n, and this is nothing but this 4 sample, that is 14, 16, 14, 16. Okay, so 14, 16, 14, 16, so we get the same result with origin at 4. 14, that is at first sample. Okay, so to identify the circular convolution by using the multiplication of two DFTs property, so initially you will determine the DFTs of these two sequences, that is x1 of n and x2 of n. After determining the DFTs, we will multiply those DFTs to get the circular convolution in frequency domain. So this is nothing but the frequency domain circular convolution, and to get it in time domain you have to take the inverse DFT. So once you get this inverse DFT, after taking its inverse DFT, we have these samples, okay, which has been identified here. Okay, so this is nothing but the process of identifying the circular convolution using DFT. So what we have done, initially we identified the DFTs of given sequences, right? Second, then we identified multiplication of the obtained DFTs, and in third step we are taking the inverse DFT. So this inverse DFT is nothing but the circular convolution result, right? So this is all for today's session. In next session we'll be discussing time reversal property as well as circular time shift property. Okay, so we'll be discussing those two properties in next session. Thank you for joining this session.